Hello everyone, welcome to my YouTube channel. My name is Arnav Jain and I'm currently working as an SDE2 at Amazon. We have already started a series on design patterns, and in the previous video, we discussed what a design pattern actually is. In this video, we are going to talk about solid principles, which are extremely important if you want to start learning and applying design patterns correctly. If you haven't watched the previous video on design patterns, I highly recommend watching that first and then continuing with this video. Alright, let's get started. So first of all, what is the goal of learning solid principles? The main goal is to make our code more understandable, more flexible, and easier to maintain over time. Let's start with the first principle, single responsibility principle, or the S in solid. Single responsibility principle states that a class should have only one reason to change. Let's understand this with an example. Imagine you have a class called invoice. Inside this class, you have three different methods. The first method calculates the total invoice amount. The second method prints the invoice. And the third method saves the invoice to a database. Now think about this carefully. This single class is doing three different jobs. It is handling business logic, printing logic, and database logic. That means it has three different reasons to change. If the calculation logic changes, this class needs to change. If the print format changes, this class needs to change. If the database changes, this class needs to change again. This clearly violates the single responsibility principle. Now let's see the correct way to design this. Instead of one big class, we split the responsibilities. We create an invoice class that only calculates the invoice. We create an invoice printer class that only prints the invoice. And we create an invoice repository class that only saves the invoice to a database. Now each class has only one responsibility and only one reason to change. This follows the single responsibility principle perfectly. Why is this approach better? Because the code becomes easier to maintain. Database changes do not affect business logic. It becomes easier to test. Each class can be tested independently. It becomes more scalable. If we want to add PDF export or cloud storage, we simply add new classes. And the code becomes more readable. Each class has a clear and focused purpose. Okay, let's move forward with the open-close principle, also known as the O in solid principles. The open-close principle states that a class should be open for extension but closed for modification. The main goal of this principle is to prevent existing code from breaking when we introduce new features, especially code that is already running in production. At first, these two terms might sound mutually exclusive, but that's not the case. Let's understand what they actually mean. When we say a class is open, it means the class is available to extend. A class is a blueprint for extension, which means you can create subclasses and override the behavior of the functions that suit your needs without breaking the parent class. When we say a class is closed, it means that once a class already exists in the product or is running in production, we should not modify it. Why is that important? Because making changes to code that is already in production is risky. It might break existing clients, break existing flows, and introduce unexpected issues. So, how do we actually apply the open close principle in real world code? The idea is simple. Instead of modifying an existing class, you create a subclass. You override only the part of the original class that you want to behave differently. And by doing that, you achieve your goal without breaking the existing behavior of the original class. At this level, the original class remains untouched, stable, and safe. One important thing to note here is that this principle does not apply to bugs. If there is a bug in your existing class, you should go ahead and fix it directly. You do not need to create a subclass just to avoid fixing bugs. Now let's take an example to understand this better. Suppose we have a class called discount calculator. This class has a method called calculate, which takes customer type and price as input. Based on the customer type, it applies a discount. For example, if the customer is a regular customer, it gives a 10% discount. If the customer is a VIP customer, it gives a 20% discount. This logic is implemented using if-else conditions. Now here is the problem. If tomorrow you want to add more customer types, you will have to add more if-else conditions. That means you are modifying existing code that is already in production. This violates the open-closed principle because the class is not closed for modification. This is a bad design. So how do we solve this problem? We solve it using abstraction. First, we create an interface called discount strategy. If you are not aware of what an interface is, then it is important that you first understand object-oriented programming. If you want, I can create a separate series on that as well. But for now, just Google what an interface is and you will be able to understand it. This interface acts as a contract and has a method called calculate. Any class that implements this interface must implement the calculate method. Now we create different classes for different discount types. For example, we create a regular discount class and a premium discount class. Both of these classes implement the discount strategy interface, and each class contains its own discount calculation logic. Now we modify the discount calculator class one last time. Instead of taking customer type as input, it now takes an object of discount strategy. Inside the calculator, we simply call strategy.calculate on the amount. There are no if-else conditions. There is no customer type checking. The discount calculator only knows that it has a strategy, and that strategy knows how to calculate the discount. Now let's see how this helps. If we want to apply a regular discount, we create an object of regular discount and pass it to discount calculator. If we want to apply a premium discount, we create an object of premium discount and pass it instead. Now, why are we able to pass the object of regular discount or premium discount to discount calculator? Because regular discount and premium discount are nothing but implementations of discount strategy. So from the discount calculator's point of view, they are the same type, which is discount strategy. Now imagine tomorrow you want to add a VIP customer. You simply create a new class called VIP discount that implements discount strategy. You do not touch the discount calculator at all. You also have zero risk of breaking change because you are not touching the existing regular and premium discount logic. This is what it means to extend functionality without modifying existing code. So to summarize, the open-closed principle helps us design systems that are safe, flexible, and easy to extend. A class should be open for extension and closed for modification. And this is typically achieved using abstraction, interfaces, inheritance, and polymorphism. And that's the open-closed principle. So yeah, in this video, we've completed the single responsibility principle and the open-closed principle. In the upcoming videos, we'll be moving forward with the remaining solid principles, the Liskov substitution principle, the interface segregation principle, and the dependency inversion principle. If you liked this video and found it helpful, please like the video and subscribe to the channel. Your support really helps this channel grow and it allows me to create more high quality content like this for you. So make sure you subscribe and stay connected because we'll be continuing this series and completing the entire solid principles step by step with clear explanations and real world examples. See you in the next video.